Welcome back to the channel. In today's tutorial, we are going to explore several essential AutoCAD Civil 3D workflows that can help you become faster and more efficient when working on engineering drawings. When beginners start using Civil 3D, one of the biggest challenges is understanding that Civil 3D is not just AutoCAD with additional commands. Civil 3D works differently because objects are intelligent. A surface is not just a collection of lines. An alignment is not just a polyline. A parcel is not just a boundary. Each Civil 3D object contains data, relationships, styles, and settings that control how it behaves and displays. Because of this, learning how to manage Civil 3D objects properly can save hours of work on large projects. Imagine working on a residential subdivision containing hundreds of parcels, a highway project with multiple corridors, a large airport project containing many alignments and surfaces. Searching manually through these drawings can become extremely inefficient. Today we will learn how to use Civil 3D tools to quickly locate objects, organize drawings, customize displays, and create reusable styles. By the end of this tutorial, you will understand some of the fundamental workflows used by Civil 3D designers every day. Let's begin. Our first topic is one of the most useful features in Civil 3D. The Prospector tab. If you have worked with traditional CAD software before, you may be used to finding objects by visually searching through your drawing. You might zoom in, zoom out, turn layers on and off, or use selection commands. However, this approach becomes difficult when drawings become large. Civil 3D solves this problem by organizing objects into collections. The Prospector acts like a database explorer for your drawing. It allows you to view every Civil 3D object and access them directly. On the left side of your workspace, open the Tool Space palette. You will notice several tabs: Prospector, Settings, Survey, Toolbox. Today we are focusing mainly on Prospector. Prospector displays the objects contained inside your current drawing. For example, you can expand surfaces, alignments, profiles, corridors, pipe networks, parcels. Each category contains collections of Civil 3D objects. For this example, we are using the sample drawing that can be found in the description box below, sample site DWG. Our goal is to locate parcel number 5 without using any AutoCAD commands. Normally, if this subdivision contained hundreds of parcels, manually searching would take unnecessary time. Instead, we will use Prospector. First, expand sites, then expand rows acres, then expand parcels. Here we can see all parcel objects contained inside this site. Notice how Civil 3D automatically creates a structured list of all parcels. This is one of the biggest advantages of using Civil 3D objects instead of simple AutoCAD geometry. Now locate Property 5, right-click on it. You will see several options. Choose Zoom to Civil 3D immediately moves the drawing view and zooms directly to that parcel. This may seem like a small feature, but on real engineering projects, this can save significant time. For example, a land development project may contain 500 residential parcels, multiple phases, different ownership boundaries. A transportation project may contain dozens of alignments, multiple corridors, several design alternatives. Instead of searching visually, you can instantly access the object through Prospector. This workflow is especially useful when reviewing drawings, responding to comments, or modifying existing designs. The next important concept is drawing scale. Civil 3D understands that engineering drawings are ultimately created as construction documents. A drawing is not only displayed on a computer screen, it will eventually be plotted, printed, or exported into PDF format. Because of this, Civil 3D allows many objects to be controlled based on the drawing scale. This includes text size, label size, symbols, blocks, annotation, objects. Let's modify our drawing scale. Currently, this drawing is set to 1 equals to 200. This means the drawing is prepared for a 200 scale plan. Now we will change it to 1 equals to 40. Why is this important? because Civil 3D uses this information to automatically adjust many annotation objects. Instead of manually calculating how large should my text be or what size should my symbols appear, Civil 3D manages these relationships automatically. This reduces mistakes and improves drawing consistency. Another useful Civil 3D feature is Object Tooltips. When you move your cursor over a Civil 3D object, information appears automatically. These tooltips provide quick information without opening properties. For example, when hovering over an alignment, you may see alignment name, station information, object details. This is very useful during design review. However, there are situations where too much information becomes distracting. Large drawings can contain thousands of objects. Having tooltips appear constantly can create information overload. Let's turn off tooltips for the Every Drive alignment. First, select Every Drive. You can select it directly from the drawing window, or you can find it through Prospector. Open Alignment Properties. Right-click the alignment. Select Alignment Properties. The Properties window opens. Go to Information tab. At the bottom left corner, you will see the Tooltip setting. Remove the checkmark. Click Apply, then click OK. Now, when you move your cursor over Every Drive, Civil 3D will no longer display the tooltip. This allows you to customize your workspace depending on the type of work you're performing. Now, let's discuss one of the most important Civil 3D concepts, styles. Styles control how Civil 3D objects look. Instead of manually changing every object individually, we create styles that can be reused. This improves productivity, drawing standards, company consistency. Go to Toolspace Settings tab. Expand, Point, then Label Styles, find Elevation Only. Right-click, select Copy. A copy of the style is created. Go to the Information tab. Rename it Elevation with Border. Now go to Layout tab, locate the text component, find Border Visibility, change it from false to true, click OK. Next, we will create a surface style. Surface styles control how surfaces appear in different views. We will create Contours Grid. This style will show contours in 2D and grid display in 3D. Click on Surface, right-click, Surface Styles. Select New. Rename it Contours Grid. Then go to Display tab. Set the view direction to 2D plan. Turn on Contours and turn off Border. Now change the view direction to 3D model. Turn off Triangles and turn on Grid. Then click OK. We have now created a new custom label style. Instead of recreating this every time, the style can be reused throughout the project. This is how companies maintain consistent plant production standards. The final topic is navigating the Civil 3D ribbon. Similar to AutoCAD, the ribbon is the main location for accessing commands. However, Civil 3D adds contextual tabs. These tabs appear depending on what object you select. Select Every Drive. Notice that the ribbon changes. A new Alignment tab appears. This tab contains commands specifically related to alignments. To access the Alignment Style Editor, select Alignment Properties, then choose Edit Alignment Style. This opens the Style Editor where you can modify display settings, colors, layers, labels. In today's tutorial, we covered several important Civil 3D workflows. First, we learned how Prospector allows us to quickly locate objects without manually searching. Next, we changed drawing scale and learned how Civil 3D manages annotation automatically. We customized tooltips to reduce drawing clutter. We created custom label styles. We created surface object styles. And finally, we explored contextual ribbon tabs. These tools may seem simple individually, but together they create a much faster and more organized Civil 3D workflow. The more you understand how Civil 3D manages objects and styles, the more efficient you will become as a designer. Thank you for watching. If you enjoyed this tutorial, subscribe for more Civil 3D, AutoCAD, and engineering tutorials.